So this is an introduction to inverse function. This is Tuesday's homework. It's due on Wednesday, and we'll continue on Wednesday with some practice in class. Now remember, inverse operations, right? Inverse operations, remember, are like adding and subtracting or multiplying and dividing. Those are operations that undo each other. Right? We've been using that concept to solve equations all year. Therefore, we can conclude that inverse functions, right? Inverse functions are like inverse operations except they're functions. They're functions that undo each other. So what that means is if f and g are inverse functions, right? It's a function f and a function g, then applying f and g is the same thing as, well, let's think about it. Inverse operations, what if I add 3 and then subtract 3? What's that the same as? What if I multiply 3 and then divide 3? What is that the same as? It's the same as doing nothing. Because they undo each other. Okay, so when we talk about inverses, we talk about things that undo each other. And the inverse of function f of x is written like this, with a little sort of exponent of -1 up here on the function. But it's not really an exponent of -1, it's just how it's written. It's called notation, right? It's just, this means the inverse function of f of x. And I can even say it like that. This is inverse of f of x. Okay? So, we're going to try some examples in a moment. And some of them are just ordered pairs, which you're going to see are really straightforward. And then when we get to finding an inverse function of an equation, here's what we do. We take the f of x, we replace it with a y. And we do that just because it's easier. Rather than moving around an f of x, we just move around one letter, right? But then what we do is we switch the x and the y. What we're doing is we're switching the input and the output. And then we solve for y, and then at the end we take that y and we replace it, right? We sort of replace the y here, and then we replace it back. So you'll see that when we get to that example. But let's start with the first example. Find the inverse of this function. So the inverse is basically if f of x takes 0 as an input and gives 4 as an output, what would undo that? Well, what would undo it is if we took 4 as an input and gave 0 as an output. Right? Then if I input 0, I would get 4. And then if I input the 4 into the inverse, I would get 0. It's the same thing as doing nothing. Here, if I input -3 and got 2, what would be the opposite of that? Well, if I input 2 and got -3. Notice what I'm doing. I'm just taking the x and the y, and I'm switching them. That's it. Right? I'm just taking the x and y and switching the places. That's all I'm doing. So for ordered pairs, this is a sort of simple task. When the x and the y are the same, then switching them doesn't change the point at all. Okay. And here I'm switching -5 and -1. This is it. That's the answer. Okay. So you go ahead and try.